All right, so in this video lesson, we're going to be looking at angle relationships in circles. So in the previous videos, we looked at what happened if the vertex of the angle was on the circle itself. Well, the measure of that angle would be half the measure of the intercepted arc. So in this video, we're going to be looking at what happens if the vertex is inside or in the interior of a circle. Okay. So this usually will happen when you either have two secants that intersect or you have two chords that intersect in the interior of the circle. So it would look something like this. So here's my circle. And let's say that I have chord AB or AD or AC in this case, make up my mind. And let's say that I have chord BD. And they intersect. And they intersect at point E. When I look at these two chords intersecting, notice that how many angles are formed? 1, 2, 3, and 4. Okay? So we have a theorem out there that says that if I have two secants or two chords that intersect in the interior of a circle, the measure of one of these angles formed. So for example, we could say the measure of angle 1. So the measure of the angle is equal to half the sum of the intercepted arcs. So the measure of the angle is equal to half the sum of the measure of the intercepted arcs. Okay? So we can say that angle 1 in this case is equal to half the measure of arc AB plus the measure of arc DC. So we would add those arcs together, take half of it, and that would give us the measure of this angle. So for example, let's say I give you a circle, and this time we're going to do a secant. Let's do a secant. So here's or let's do two secants. So for example, here's two secants. We're going to call this P, Q, S, R, and T. And they want you to find the measure of angle SQR. Okay? And they tell me that the measure of arc SR is equal to 100 and the measure of arc PT is equal to 32 degrees. So to find the measure of angle SQR, we have to take half of these two intercepted arcs added together. So the measure of angle SQR is equal to half the sum of the measure of arc SR plus the measure of arc PT. So the measure of angle SQR is equal to half the measure of SR, which is 100, arc SR, which is 100 degrees, plus the measure of arc PT, which is 32 degrees. So then when I add those together, we get half of 132 degrees. Half of 132 degrees is 61, or not 61, 66. So therefore, the measure of angle SQR is equal to 66 degrees. That's pretty much it. So if I have a vertex that's in of an angle that's inside the circle, we take half the measure of the sum of the intercepted arcs. All right, as always, if you have any questions for me, please feel free to send myself or Mr. Art an email, let us know, or ask us to set up a Google Meet. In the second video of this, we're going to be looking at what happens if the vertex falls outside the circle. All right. So until then, we will talk to you later. Have a great day.